Scientific theory is the result of careful observation, analysis, and prediction of natural phenomena. Scientists strive to understand the reasons behind these phenomena and how they occur. They collect information and materials, conducting extensive research and review. Based on various data and observations, a tentative hypothesis is formulated to explain the phenomenon. It's important to note that a scientific theory is not the invention of a scientist, but rather a culmination of facts and observations. However, simply having a hypothesis supported by data is not enough to establish it as a theory. There are three conditions that must be met for a theory to be considered scientific. Firstly, the basic rules of the theory should be simple and rely on few assumptions. Secondly, the theory must accurately explain a significant portion of observed phenomena. And finally, the theory should be able to predict the recurrence of the event in question. To fulfill these conditions, events are observed, interpreted, and predicted using the theory. These predictions are then compared to the actual outcomes. Only after repeated testing and verification can a hypothesis attain the status of a complete theory. The theory is sustained by continuous testing, with the aim of proving it wrong. The journey from hypothesis to theory involves 4 steps. Firstly, the hypothesis undergoes rigorous testing based on scientific principles and logic. If it withstands this initial testing, it moves on to the next phase. In the second step, artificial environments are created, or data from natural environments are analyzed to test the predictions derived from the hypothesis. In the third step, the predictions are compared to predetermined outcomes. If inconsistencies or errors are observed, the hypothesis is revised and new estimates are made. If the test results align with the predictions, the process is repeated. However, if the results are inconsistent, the hypothesis is discarded and a new one is sought. A hypothesis is accepted as a scientific theory only if consistent and correct results are obtained through repeated iterations. Once a hypothesis is established as a scientific theory, further conclusions can be drawn from it. If the theory can properly explain the natural phenomenon and related phenomena, it may be given the status of a scientific formula or scientific law. It's important to note that a correct and established theory is supported by thousands of observations and predictions. Any wrong predictions or misinterpretations can undermine the theory's status as science. However, by correcting these errors, a new hypothesis may emerge, leading to the development of a correct theory and its establishment as science. Therefore, an established theory is not inferior to proven science. It may even lay the foundation for future applied sciences, much like Newton's laws of motion did in their time.